Welcome to this video presentation by the postgraduate student whose poster it represents. We will miss the bustling crowds around the posters at the All Energy Conference this year, but we hope you enjoyed this online version that we have created. Before the presentation starts, I would like to acknowledge the support of our generous sponsors. Without this support, the competition could not proceed and the winning entrants would not receive a financial award. Our platinum sponsor is the Victorian Government through the Department of Environment, Land, Water and Planning. Its brands include Victorian Energy Compare, Victorian Energy Saver, Victorian Energy Upgrade Program, Energy Scorecard and Energy for Business. Their contact details are on the slide. Monash University's Monash Energy Institute is one of our silver sponsors. With over 170 staff involved, the Institute has a vision to bring people together to solve global energy problems. The Monash student posters in this competition represent some of that work. Baywa Renewable Energy is another silver sponsor. Baywa develops both wind and solar projects in Australia as part of a global energy portfolio. Baywa staff have also supported our AIE events in the past, including our Young Energy Professionals Speed Networking events. Our final silver sponsor is the University of Melbourne's Melbourne Energy Institute. Many of you will have attended their regular forums that keep the energy community and public up to date on technical and policy energy matters, and the University of Melbourne posters in this competition reflect some of that work. Seed Advisory is our bronze sponsor, and this small but well-recognised energy consultancy covers both the technical and regulatory fields. Seed Advisory has been a regular supporter of the AIE and a presenter at our events. Lastly, we thank All Energy for hosting our live poster events over the last decade, and we look forward to doing this again post-COVID. These last slides show you our poster winners in the last competition. And I now hand you over to the poster presentation. Thank you.
Hello, good day. I'm Carmen, and today I'm going to present my work on planning power systems under uncertainty. Power systems are now subject to unprecedented levels of uncertainty, and new flexible investment options can mitigate these effects. Therefore, conventional power system planning that uses deterministic optimization needs to be reassessed to include decision-making tools that assess uncertainty and new flexible investment options like storage. However, most planners are unsure on which decision-making tool will be the best candidate to include in their planning methodology, usually considering stochastic optimization, least worst regret, and robust optimization. In our work, we discuss the suitability of these decision-making tools to a planning problem, and we compare the cost and risk implications for the planner. The first step of our work is to analyze what are the characteristics of decision-making in power system planning and how different decision-making tools fit in those characteristics. The characteristics we identified was the fact that long-term uncertainties are better represented by scenario analysis, that decision makers are interested in an investment evaluation across all feasible scenarios, and their investment strategies are multi-stage strategies. Finally, planners want a level of risk management in their decision-making process. We found that stochastic optimization and least worst regret are suitable decision-making tools for planning power systems. The next step is to develop a planning methodology that allows to compare decisions and implications of using these different decision-making tools. We modeled uncertainty through scenarios that is included into a planning distribution network model as a mixed integral linear program, where There are two different investment options of different nature: line expansion and utility on batteries, and a network model that allows to include customer-owned resources and linear power flow. This planning distribution network model is a set of constraints that is then fulfilled by the objective functions of least worst regret and stochastic optimization respectively. This way, each decision-making tool will give us an expansion plan where we can compare the investment decisions and the expected cost and risk of using each decision-making tool. We use a simple case study to study these differences in decisions and implications. We use a 10-bus distribution network with customer-owned DER, and the uncertainty was modeled through a 2-stage and 3-scenario setting, where 3 different scenarios have different values of DER and peak demand. We see here that stochastic shows lower expected cost. However, this worst regret provides more risk control by reducing the maximum expected regret. Also, we are comparing only including line investment to including line and battery investment. And what we can see is that including batteries reduces the risk. So including this type of investment options is helpful for the planner to mitigate the effect of uncertainty. This second set of results focuses on decision-making tool comparison. On the one hand, we have the investment decisions when only considering deterministically one scenario, scenario 2 and scenario 3, and when considering 3 scenarios through stochastic or least worst regret. First of all, including uncertainty involves more investment in batteries, even when compared to the worst case scenario deterministically, which would be scenario 3. And also, least worst regret relies more on flexible investment options to equalize the regrets among scenarios. The conclusions of our work and the main ideas are that it's important to address the suitability and implications of each decision-making tool to help in the adoption in planning methodologies. It's important to include in planning methodologies flexible investment options as they can help to manage the risk for the planner, and also including least worst regret or stochastic optimization, which provides better risk management than deterministic analysis. Each decision-making tool provides different risk attitudes that can be useful depending on the planning needs. Thank you very much for your attention.